Assalamualaikum and a very good evening to Professor Dr. Azhar. Today we're going to present our machine learning project titled Decision Tree Algorithm. So this report is prepared by Faezah, Nursyaza, Nisa and Safinah. So firstly, the decision tree is an algorithm under supervised learning and a non-linear classification model. So this algorithm not only suitable use for classification but also regression problems.
As an introduction, purpose of us writing this report is to present a detailed explanation of applying the decision tree algorithm on the Titanic dataset, which is the dataset that we have chosen for this project. In this report as well, we will be presenting the knowledge we gained throughout the whole course of machine learning and include visualizing the decision tree as a result. Next, as of the overview, we will be using the training Titanic dataset to explain the details of using the decision tree algorithm in determining whether the passenger in the Titanic ship will survive the crash or not. And the training Titanic passenger survival dataset contains 891 rows, which will be used to develop a high-performance predictive mode.
For the project background, it provides information for anyone who desires to learn ways in retrieving CSV file, how to drop and add features to the data set, identify the numerical and category variables, identify missing data and replacing missing data. It shows the method of transforming, which is mapping of categorical variables into equivalent numerical values, transforming variable range into discrete bins, correlation between all of features and survival and correlation between each feature which is in heat map. The model evaluation and selection which is parametric tuning for the selected model, careful cross-validation for the selected model and variable importance for the purpose model will be presented as well. Prediction of the target value, which is survival of the test data, and submitting the final result will also be included. This data is chosen as it is simple and thus is allowing us to focus on using classification algorithm which is decision tree. We have three objectives, which is the first one is applying decision tree technique, the second one is illustrate decision tree algorithm, the third one is to improve the performance decision tree algorithm. Okay, we have exploratory data analysis, which is we need the data loading and description of data. The dataset already consists of the information about people body of the famous Titanic ships. It contains variable includes data of age, sex, fare, ticket, and others. We will implement this dataset in the Python language. First, we needed to import the necessary package. This is all of the necessary packages we needed in this dataset. Then we will import the Titanic dataset from the githubcontent.com. Then we will print the number of training, the training shape which is 891 and 12, the test shape which is 891 and 12. Here we can see the info of the Titanic dataset, which we use this command printdftrain.info. Here we will use the dftrain.head which show the first 5 rows of the data, which is this data we can see from here. Then we will print the test info also. Next, we will process the data which is dealing with missing values. Here, I will use this command def display missing df. Here show we have 3 missing features which is missing value is age, cabin, and embarker. Here is needed the command in H, and the embarker. This is the graph that we will present, and we have the fair. Here are we plotting the relationship between fair, age, P class, and survivor. So from the observation, as we can see of the more people of P class 1 survivor then die. More people of P class 3 died than survive. More people of age group 20 until 40 died than survive. Most of the people paying less fair died. We will establish the creation of training and test set, and we will present them in heat map. Here is our heat map. We have the target distribution, which is 38.38%. Training set is class 1, 61.62% of training set is class 0. Here is the graph, as we can see, how many percent for the not survive and survive. And then the target distribution in features, we have continuous. Also, we have categorical. As for the continuous, we can say that the both are continuous feature which age and fair have good split points and spikes for decision tree to learn. This is our command. Then this is our graph is distribution of survival in age. From the observation, we can see that it's clearly show among 25 years old, it has a higher survival rate than any other groups here. Here is the distribution of survival in fair. We can see that the survival rate is higher on the distribution tails. The distribution also have positive skew because extremely large outliers. And this one is categorical features which needed that at least one of class with high mortality rate. We will run this command which is cat features and bucket parch, P class, sex, and SAB SP. Here is our plotting graph. Yeah, we can observe that the best category features are P class and sex because they have the most homogeneous distribution. Passenger boarded from Southampton has a lower survival rate unlike other ports. More than half of passengers boarded from Cherbourg has survived. So this observation could be related to P class feature. Patch and SIB-SP shows that passengers with only one family member have a higher survival rate.
Okay, so next we'll perform future engineering. So one of the future engineering technique is binding. So in binding continuous future, we can see that the fare is positively skewed and the survival rate is extremely high. And then next, for the age, we can see that it has a normal distribution with some spikes and bumps, and 10 quintile base bins are used for age. So here's the graph. So from the graph, we can see that the first bin has the highest survival rate, and the fourth bin has the lowest survival rate, and those were the biggest spikes in the distribution. Okay, so next we have the next technique of future engineering, which is frequency encoding. So in frequency encoding, we use family size, and then uh, here is the rest of the coding. And next is we also use ticket for for the future engineering. And then there are too many unique tickets values to analyze. So grouping them up by their frequency makes things easier. So it differs from the family size that we can see above, as there are many passengers travel traveling with groups. Okay, so this is the graph. So based on the graph here, we can see that the groups with 2, 4, 6 members had a higher survival rate. And then we have title. So the title is created by inserting prefix before the name feature. And based on the graph, there are many titles occurring. There are many titles occurring. And then next we have target encoding. So in target encoding, we extract surname function for of passengers of the name feature. And then the family features are created with extracted surnames. For the family survival rate, we calculate from the families in training set since there is no survive feature in test set. And then an extra binary feature, family survival rate, and A is created for families that are unique to the test site. This feature is necessary because there is no way to calculate those family survival rate. This feature implies that family survival rate is not applicable to those passengers. There is no way because there is no way to receive their survival rate. And then ticket survival rate and ticket survival rate and A features also created with same method. Then we have the feature transformation. So in feature transformation, we have two, which is label encoding non-numerical features and one hot encoding for categorical features. So in label encoding non-numerical features, we have embark, sex, deck, title, and family size group because they are object types, and age and fair features as category types. So in one hot encoding, we have P class, sex, deck, embark, and title. Next, we have the decision tree. Decision tree is one of the most frequently and widely used supervised machine learning algorithm that can both perform that only that is not suitable only for regression but also classification. So we have important terminology related to decision tree. For example, there are root node, splitting, decision node, left terminal node, pruning, branch, parent, and child node. Next, we have Gini impurity.
For the gene impurity, before we want to build a decision tree, we have to find the best split for each node of the tree. So in decision tree, the commonly used metric for it is to uh, use information gain. But in the sklearn library, there is this thing we call gene impurity that uses the common measure as information gain. So we use gene impurity in our code instead of calculating information gain manually. Okay, based on the DF train of grouping of sex and survived, we can see that the mean, which is the survival rate, the count, which is the total observations, and the sum of people survived, which female is representing by 0 and male is 1. Next, we will calculate the Gini impurity of the starting node, which is the first node of the decision tree. Next, we will be performing cross-validation to find the best step for the decision tree. Before that, we need to drop the elements from the feature engineering that we will not be using. And then we will train and test the data. After that, we will find the maximum depth and the average accuracy that we will be using for the final decision tree. Lastly, we will import tree function from the sklearn library to build a decision tree based on the train test data that we built. And based on the coding, we see that this picture is the final decision tree. And from the tree above, we can see that the first node starts off with 549 passengers, which are not survived, while the remaining of 342 over 890 survived the crash. In the end, we can conclude that the passengers with family size less than or equal to 4 and with title other than Mr., Mrs., Miss, and Master have 21 of them who did not survive the crash, while the rest of them with the title actually managed to survive. For passengers with a socio-economic status less than or equal to 2, which are upper class and middle class, only 6 of them survive and not the rest in the lower class. And that is the way to interpret the decision tree.
In conclusion, decision tree algorithm is a supervised machine learning technique that covers both classification and regression. So this decision tree is used to create or derive new features using a combination of features from the original dataset. So what decision tree does is the small groups of features are selected from the columns in the training dataset and are used to train a submodel, usually what we call as decision tree. And then from this project, we can conclude that feature engineering is a very important step in machine learning. So by having feature engineering, engineers can analyze raw data and potential information in order to extract a new one or more valuable set of features. So these artificial features are then used by the algorithm from feature engineering to improve performance, or in other words, is to reap better result. That is
Okay, that's all from us.
Thank
Thank you.
you.